two-dimensional array. An array of arrays is known as two-dimensional array. We know that in the case of a single dimensional array, that will contain only one row and n number of columns. But in two-dimensional array, that contains n number of rows and n number of columns. So we can say that a two-dimensional array will be the collection of one-dimensional array. The two-dimensional array is also known as a matrix. A matrix can be represented as a table of rows and columns. For explaining that, we can take the example of A3, 3. In that, A is the array name of the two-dimensional array, and the first 3 represents the number of rows present in the two-dimensional array. Then the second 3 represents the number of columns present in the two-dimensional array. So we move to the example of A33. So this will be the visual representation of two-dimensional array A33. So these are the 3 rows present in the array A. So this will be the first row, and this will be the second row, and this will be the third row. So these are the columns present in the two-dimensional array A. This will be the first column, second column, and third column. The next is how we can point a particular memory location or a particular element in the two-dimensional array. So with the help of the index number, we can easily point a particular memory location or a particular element in the two-dimensional array. The two-dimensional array contains 2 index numbers. One is used for pointing the rows and the other one is used for pointing the column. So in the case of row, the index number will start from 0, 1, 2 like that. And in the case of column, the index number will again start from 0, 1, 2. Then always keep in mind that the index number will start from 0 onwards. So we move to the first memory location. This first memory location will have a unique number. That unique number is A00. Here the first 0 represents the index number of row 0 and the second 0 represents the index number of column 0. In the case of a second memory location, its corresponding unique number is A01. Here, this 0 represents the unique index number of row 0 and this 1 represents the unique index number of column 1. So with the help of this index number, we can point any of the memory location or any of the element present in the two-dimensional array. The next is how we can find the storing capacity of a two-dimensional array, or how we can find out how many number of elements we can store in a two-dimensional array. For that, we will have an equation that is the total number of elements present in the two-dimensional array will be the row size into column size. For explaining that, we goes to our previous example, that is A33. So the total number of elements present in the array will be equal to 3 into 3. Here the first 3 represent the row size and the second 3 represents the column size. So 3 into 3, that is equal to 9. Then next is how to declare a two-dimensional array. For declaring a two-dimensional array, we have to follow a particular syntax. That is the data type, the name of the array, then inside the square bracket we will have x. That x represents number of rows present in the array. Then we will have y. That y represents number of columns present in the array. So example of the declaration of two-dimensional array is int a 2, 3. In that, this int represents the data type of the element present in the array. Then a represents the name of the two-dimensional array. 2 represents number of rows present in the two-dimensional array. And this 3 represents number of columns present in the two-dimensional array. Then this is the visual representation of the two-dimensional array A. This contains 2 rows. This will be the 0th row and this will be the first row. Then it contains 3 columns. This will be the 0th column, this will be the first column, and this will be the second column. And this is the end of part 1 two-dimensional array. Then